Good morning. All right, fourth day, including the day that we registered for this session. I'm thankful that you all are here today. All right, let's quickly move to the next slide. We are going to talk about monitoring critical applications. Can we move to the next slide? Clicker. Well, I don't want to go through this slide. You know this. Let's go to the next slide. Thinking about monitoring critical applications, I just was trying to look for some analogy. What was the most critical thing that happened in the recent past? That reminded me of the days that we were all locked up in our rooms during pandemic, having that small device pulse oximeter, checking blood oxygen level for everything. Was that enough? It wasn't. That is discrete monitoring, isn't it? When for a critical patient, he needs ICU, intensive care unit. So there, the monitoring is continuous. All the vitals of the human body are continuously being monitored. Just like how a human body is one entity with multiple vitals which all need to be continuously monitored, critical applications, when I say critical applications, business critical applications, the downtime of which may cause huge revenue loss, need continuous monitoring. That's what is the session that we are going to cover today. We will move to the next slide. We will skip this. I'll just quickly talk about that. We are from VMware IT. I'm Jois. With me, I have our observability expert, Magin. We are going to talk about how we have implemented monitoring critical applications within VMware IT. Thankfully, we have the best products at our disposal, and we are the first users of our own products. We call it as customer zero. If we engage in beta phase, and if we are working with the GA version, we call ourselves as customer one. We closely work with R&D. Before any VMware product gets launched here, we test it on scale, on our own environment. All right, so I don't want to just cover this slide, just move on. This is what it is, right? We reveal our joys and success and conceal our pain. I just quickly want to check. You all must be running your IT shops. How many of you have legacy systems, monoliths? You think that's not outdated, not current? Well, I'm surprised. I thought everybody's hand will go up. Same with us too. There are so many legacy systems, either we don't have time to update them, or technology has moved so fast that we are lagging, or it may be funding thing, or it may be just it's running, let us keep it running. So we wrap it around, and make it more and more complicated. With modern business applications which run on hybrid cloud, generally modern enterprises use more than one cloud these days. With private cloud and then multiple SaaS solutions, applications are becoming more and more complex. That is far more true with microservice architecture, where the runtime decisions are happening. So you don't know which is running where. That is a typical situation that an IT admin goes through. But as an user, I don't care. I send a request, I need a response. And I need it. I need high available systems performing best whenever I access any portal or any business critical system. That's what it is. So, as an IT infrastructure administrator, this is what happens. There are so many moving parts. There are constant upgrades and updates. That is for the system that we support, not just that, even for SaaS systems, and there are always compatibility things that we need to look on. Configuration changes happening. That reminds me of one minor configuration change on one of the SaaS system of one of our vendor, where a space got added to config file. That caused hours of downtime and major revenue loss. And diversity of architecture. So what would it lead to? That is what the IT admin says. He says, I'm dealing with something that is outdated, it is not built to scale, and nothing was changed. Even if something has changed, it was just a minor, small space within the config file. That's what IT admin says. Let us see what application owner has to say. Right? Application owner doesn't care. Right? Business is moving so fast, they need everything to be implemented, and they need it as on date. Right? Well, here is application owner's point of view. He needs high available system, which is seamlessly scalable. Of course, if it is on containers, that's possible during runtime. He wants low latency and best performing systems, and He doesn't know what is running where. He need to launch it as soon as possible, and if anything goes wrong, infrastructure team is at fault. Tell me what went wrong, right? That's the point of view of an IT admin and application owner. Let's move to the next slide. Well, now we from observability team are kind of between application owners and infrastructure admins. I want Magin to cover the challenges as observability engineer here.
Yeah, thanks, Jois. So let me cover the challenges that we face from the implementation of monitoring or observability, right? So if we just go point by point, one would be, probe conflicts in the sense whether I will be able to deploy a probe or a system to monitor that particular component, right? One of the hurdle is, I mean, it's for a reason, would be from the security, regulations. Why do you need to have an agent installed on that particular system? Why cannot you do it remotely? And if you do it remotely, what all holes need to be punched, right, in the firewall? So all these things will come up at the end, because generally what we have seen is monitoring or observability is considered as an afterthought, which should not be the case. It should be a shift left approach, right? It should be at the first, during the development phase itself. We will talk about observability-driven development in a while. So this is one of the challenge. The request comes at the very end moment, and we have to go through the what you call the security approvals and all those things if it's a new component that we are going to put into it, right? Okay. Next thing is lockdown or legacy systems, which does not let you do anything with respect to instrumentation, or whether there are no hooks to do some proactive monitoring to it. So we call it as black boxes, because once the data enters, or it is completely unaware, or it's not able to provide the state, until it comes out of the system. Okay, so that's the one challenge with the legacy systems that we faced. We are trying to find out workarounds to implement observability in that systems as well. So we have some use cases that we are we are doing some POCs on it, in certain cases, what we can do to circumvent these issues. So develop once, deploy anywhere, right? So as Joyce said, we don't, as an application owner or the monitoring system we don't really know where the workload is deployed, whether it's in local data center or it's in multi-cloud or hybrid. We need to have an approach to tackle all these.
Yeah, and Magin, particularly for public clouds, they come with their own monitoring set. You need a solution which actually can take data from their monitoring systems point and integrate at one view, actually.
Yeah, heterogeneous, we have all kinds of system. Oh, okay, so this is one of the key challenge, right? Application owners want to monitor everything. What is everything, right? And what it ends up with, too much of noise. The alerts that are not actionable, and which causes the real actionable, alerts to go below the pile, right? So this is one thing. We need to be judicious of what are really actionable insights, right? So that need to be well defined. We need to work with the system team and the application team. So this requires, few back and forth engagements with them.
That actually, I emphasize the point that I mentioned earlier. Discrete monitoring is about you fire an alert, and based on the alert, you take action. But that doesn't work. Just the volume of data that we have in our system, we have 120,000 events getting ingested every second from our logs.
Yeah,
you can't depend on it. And many times, it's kind of repercussions. The root cause will be something. Some small network blip might have caused hundreds of alerts. And they may be transient, they're non-actionable, they're actually not the root cause. You will need to figure out the root cause, basically. You should be able to correlate everything.
Yeah. Yeah, so one hat doesn't fit all. So in that case, one size doesn't fit all. So we need to have multiple tools. That's inevitable, right? So the thing is, if we have different set of tools, how do we converge them to one place, right? Because we cannot have multiple or 15 or 16 screens, to look at and act on, right? So that is one of the challenge. We need to have a single pane where we can converge all these alerts and use as a single pane. And as we have multiple tools, there is a high learning curve, right? the team members should be able to manage and work on those tools. So and these tools keep on changing as well, right? So this is another challenge from the monitoring perspective. Yeah, application and service tracing, because with all our modern distributed microservices architecture, tracing is very important and key, right? So what do you think about observability-driven architecture?
See, it's very important mainly because there are multiple teams at play here. Even if, say, for example, gone are the days when VMware was just selling perpetual licenses. It used to just get logged in our system. It is not like that now. Any end user may be requesting for any subscription anywhere through our partners, through our distributors. Those requests come to us. If anything happens in that transaction, end-to-end transaction flow, there are multiple teams at play there. You will need to stitch everything together. And to be able to do that, you should instrument your code. It is shift left, just like how DevOps started. Observability shouldn't be an afterthought. Yeah. When you are designing the system, you should consider observability, and that's what observability-driven development is all about.
Right. So, but how easy or difficult is to inculcate this culture within the development?
It's very difficult because it's more of a processes and mindset. It's a mindset change basically. It is than the tools. Actually, tools are capable, but if you are addressing monitoring and observability as an afterthought just for compliance sake, then you will not be able to achieve it. I mean, thankfully, we have the ability to instrument existing systems, right? You can make it traceable. You don't need to do major code changes. You need to add libraries and make it observable.
Yeah, so we just went through the key challenges. And this is how it used to look, right? We have multiple solutions. And all these are multiple tools. It's not just like within one tool. So this is how a NOC would look like, right? So you see an alert in one screen. Now the thing is we need to correlate with what happened beneath that, right? So that's another tool. So this is what you call the siloed approach that we used to follow, and this is what we are looking at as the end result, right? So this is where we will have a top-down approach within one pane. Okay, so we start with the very basic high-level view, whether my service is up and running or not. Okay, it shows okay, it's all fine. Now, how about the performance? What is the response time? Okay, within the limit, all good. Now, if you want to, you can drill down deep into the other stacks or the stacks beneath it, or independent applications or services that we can use do with the other widgets. We see. We have segregations based on the data centers, and its availability is shown. And what we have done is we'll show it in a demo. We can actually make what you call panels within the dashboard for each of the component, right? And you can just expand it and see how's the state of it. We'll see that in a demo, demo video. So this is, this is the ideal state we should be in. So we don't have to jump across multiple systems. And with that, we will go to a few use cases.
Yep.
Okay. So these are the use cases that we have in our IT environment. So we'll take two use cases.
Should be good to cover 2 use cases.
In the interest of time. So this is a custom dashboard that we have built for monitoring our internal container registry. Okay. So this is a widget. This encompasses the entire architecture or the service. So from the NS1, which is a monitoring service, DNS service, and we have different views for the metrics of our interest, right? So if you see, this is the login response time for login pages from multiple locations. Okay. So how do we do it? For external monitoring, we use a third-party tool, and that is integrated with Aria Operations for applications, and that's how we get this data in.
So we should actually mention about the number of integration that Aria Operations for applications has, right?
Okay.
More than 250.
Yeah, it's the default or built-in integrations are more than 250.
The product that we are talking about is Aria Operations for applications, which we used to call Wavefront, Tanzu Observability before. Now it is called
Tanzu Insights.
Tanzu Insights. Yeah, that's the product that we are talking about.
Okay.
That's our main product for single pane of view for our command center.
And coming down, it is the GTM status for the VIP. So right now it is being served from SE2. And okay, we didn't have this completed, so this is for the VMC data center. So what will happen is if there is a service issue with SE2, it will flip to the VMC as the backup data center, and we'll see that this coming up and this turning down.
So, well, each region have multiple data centers.
Yeah.
SE2 is one of our data center. Likewise, we have all the data centers listed there. This whole dashboard is crawlable horizontally and vertically, and then further drill down that Magin is going to show.
Okay. So it's the same widget on the other side. There's a different visualization. Yeah, this is based on the request from external, different locations. And these are the details of the proxy. Or if you see, currently it is being served from SE2 data center. And this is how easily you can create a widget. Okay, let me play this. So this is a metric which determines the state of it. Okay, and it's a kind of a binary, 0 or 1. If it is 0, it is in error state. If it is 1, it's WDC. So it's currently running from SE2. Details with respect to the L1, Nginx proxies, the active connections, request rate, all those details are there. And the file system for these proxies. If you see here, we have 4 nodes, okay? So this is the backup one, backup DR side. It has 2 nodes, and all these, vital informations are shown as small, easily readable widgets, okay? So if you see anything turning red, that requires attention, right? So it gives visual cues to what need to be taken care, and this is our TKG environment. If you see, we have both the C2 and WDC for each of these components because it's running on a DR state.
The idea is to identify anomaly even before it becomes a major issue. So correlate them together. That's what these graphs are all about.
Yeah, you can see, it's a higher heat source CPU usage on SC2 because this is not actively being used. So you'll see all these parameters being slightly skewed on the SC2 side. Similarly, we have Postgres clusters, both in SC2 and WDC. The parameters of those interest, like buffers, these are specific to Postgres.
In interest of time, can we move to the next use case, Magin?
Yeah, okay, I'll do that. So that was an active standby environment. This is active. This is being actively served from multiple locations. This is the VMworld, environment that we had last year. So it was called VMworld back then. So again, we have bifurcated based on the components, right, starting from the URLs. Is it not playing? Yeah, so you can see the bifurcation of each component. You can just expand and see what the state of it. We just start with the web page. Within the web page, we have multiple components. How is its availability? This is on a global scale, okay? So for each of the pages, what is the latency? And from external locations, from UK, the US, West and East, how is the response time? Coming to the auth layer. How is it all performing? The load balancers, for each of the service, for the MySQL service, and the controller status for the VIPs, MySQL cluster-related details, how many are active, all those details are shown. So the point is, it's very easy to create custom dashboards. Just that you need to have the data, and we have multiple, options of widgets that can suit the visualization format that you need, right? Okay, so just to close this up, we'll go to the next use case. This is on the tracing part. So this is the application trace map when it says, okay, these are the interlinked applications or services when it comes to tracing. Okay, so this is because we have enabled and instrumented our applications. And if you see, just to start with, we have these 24 applications, and it shows the map of how these are interconnected to each other, right? So it gives a visual cue, which is very important, right? Because things change every now and then. Just seeing it, okay, now this is taking a different route, okay? Or it has failed over. So we'll be able to see those, live changes in real time. So this is that application map. Just fast forward it. Okay, so this is the trace browser. If you go deep into the tracing part of it. So these are individual transactions that are happening. Okay, so if you just take this example, right, of authentication happening to the API gateway for my VMware. So this is one of the flow in that system, right? So the hit gets, this auth system gets the hit, and it does a lot of things like validation and authorization. Then it forwards that to the gateway, right? So all these steps that we see are actually the spans that are happening within that service. We didn't have this visibility deep into what is happening within the service, but with traces and instrumentation, we will be able to see what actually is being happened within the scenes and what response time or how it is performing. And if you find a breakpoint there, instead of saying that, okay, this particular service is failed, we will be able to tell which span or which, sub-process in that service is actually causing issues, which is very helpful in troubleshooting and decision making as well.
And,
right?
and mainly the red matrix is going to indicate what is that user might be experiencing. Digital experience monitoring, it's kind of number of requests that you get, how many of those error, and what is the
average
performance,
duration,
average duration that their requests are taking. So this will help us understand overall health of your system.
Right. So this very derived, it is a very key derived metric, request, errors, and duration, right? So with this, we will be able to guess or assess the performance, how it is going on.
Can we cover the takeaway? We just have 2 more minutes.
Yeah, okay. So we have seen, what our challenges were, being dynamic and complex and all those things. We see the challenges with respect to observability. Now with Aria Operations for applications and its surrounding ecosystem, now we have a common metrics and observability platform. Okay, we have dashboards, we have visual indicators, which is easy to navigate at times of need. And other thing is, it has an intelligent alerting engine, right? So instead of gone are the days where we used to set static thresholds. Now it can assess the performance or the metric or period of time and come up with dynamic thresholds, right? Which eliminates a lot of transient alerts that happen. And reduce, obviously, the after effect of all this is reduced time to identify and,
the root cause.
And isolate the root cause.
Yes.
So these are the...
Yeah, it is not that we have 100% perfect system. No, we don't. It is a moving target. Just because we have such good products, we are able to, probably we are a few steps ahead of the rest of the IT shops.
Yeah. That's it.
Yeah, the key functionality, you need to make sure that your alerts and
It is.
are tagged so that you could build application topology and make sure whatever tool you're using has wide integrations. We talked about Aria Operations for applications, more than 250 integrations, including the monitoring solutions that the public clouds, AWS, GCP, and all provide, and interoperability between all the monitoring tools we have. We in fact stopped looking for one-stop solution. We also have multiple monitoring systems, but what sits on top of it is this tool. It's helping us for better availability and performance. Thank you.
Yeah, thank you.